Hey everyone, welcome to Getting Started with React. This course is going to cover everything you need to know to get up to speed with React. We'll start off by discussing why React is different from all the other frameworks and libraries out there. Then we'll start writing our first components with JSX, and we'll also compare JSX to React.dom. Once we understand the difference between the two, we'll focus on the core concepts of writing components. We'll see how we can manage our state with React, and use props to trickle the state down to any child components. Using events and refs, we'll see how we can get a handle on the DOM to interact with it. With these concepts down, we'll take a look at some best practices with React. We'll learn about the one-way directional flow of data, which will allow us to easily manage our application's state. We'll also compare two-way data binding in Angular to the way that React handles this. Then we'll see how to set up build processes in React. We'll cover transforming our JSX with the React tools and managing our dependencies with Browserify. At the end, we'll build an application to cement all the topics that we've covered. We'll build a real-time news voting application with React and Firebase. If you've been wanting to learn why React is different from all the other frameworks and libraries out there, then this is the course for you. Hey everyone, in this lesson we're going to focus on why React is different than the other frameworks and libraries out there. Before we write any code, we should really understand why we want to use React. What is the benefit it offers, and why is it so different? React is a Vue library, so it's not a full MVC framework, it's just the V in MVC. It's one of the newer libraries in the front-end space, and it's a product of Facebook R&D. So if you ever wonder if this can be used in production, just know that Facebook uses it, and it essentially powers the Instagram web client. So it's pretty safe to say that you can use it in production for your app. Why would we want to use React though? What makes it different from all the other frameworks out there? Is it just syntax, or does it really do something different? The biggest reason why React stands out amongst the rest is due to the way that it manages state. And this is mostly to say that it doesn't really manage state. To really understand that, let's have a history lesson. 15-20 years ago, web development was a lot more simple. The user would enter a URL. That would hit a web server. The web server would generate HTML and then send it down to the browser. The browser was just responsible for rendering the HTML. Now, if the user wanted to interact with the site, this would involve a post back to the server, which would deliver new HTML to be re-rendered. While this process was slow, it was very simple. Every time we wanted something to change, we could just easily re-render the page. This process became much more complicated with the advent of AJAX. When the XML HTTP requests hit the scene, we can now send out-of-band HTTP requests to update just fragments of the page. And this was a heck of a lot faster than posting back for every change. And XHR gave way to the single-page apps that we write today. Now we could load one page and update it with small requests and have the browser do all the heavy lifting. And this is the core philosophy behind frameworks like Angular and Ember. This new single-page approach is a lot faster, but it also brings a lot more complexity to the client side. We lose the ability to re-render the entire page. We have to know which parts of the page to update, and this is all based off of our application state. Let's take a look at this app as an example of managing state. It's just a to-do list. Every time we add a new to-do, it'll append to the list. That's one behavior that'll make our state more complicated. We'll also have to be able to complete to-do items. With a single-page application, all of these actions directly mutate our state. We can't re-render the entire list because it's too inefficient. The bottleneck for performance is usually the DOM, so we want to operate on it as little as possible. It would be a lot easier if we could just re-render our application and not have to deal with the slow DOM. Well, with React, we can. But the DOM is slow, so how does this work well? Well, React has a JavaScript implementation of the DOM called the virtual DOM. This is completely separate from the browser's implementation. Every time state is changed, React creates a virtual DOM tree. It diffs from the current one, and then re-renders only the difference to the real DOM. This means we get the benefit of re-rendering off state changes without having to deal with the slow performance. React deals with representing views with components rather than templates. In modern frameworks and libraries, we use templates to structure our markup based upon our application's state. In this case, we're generating a list of items using an Angular directive. Our state is this array of items. React sees a problem here. Templating is a domain-specific language. It's not natively available in HTML or JavaScript. Angular here has created an abstraction that gives us this functionality. If Angular doesn't provide the functionality we need, we'll have to go out and create it ourselves, which increases the complexity of our application. React argues that the better way to do this is with components, and these components are just JavaScript. React provides us with a set of functions that represent HTML nodes. Using these nodes, we can build our own custom components. Since this is all JavaScript, we don't lose out on any of the expressivity of the language. However, there's one drawback to this approach. We lose out on the visual representation of our view. In templating, it was easy to see how our view would be rendered, because its structure is similar to the end result. This is why React created JSX. JSX is the syntax that React uses to represent the view, and it's just sugar that renders out to these functions. But there are a couple tricks we need to know to get it to work. In the next lesson, we'll make our first component using JSX. React is a component-based library. At this point, it only makes sense for us to write our first component. In this video, we'll cover everything you need to know to define and render your first component. Here are the main topics that we need to know. First, we're going to see how we properly transform JSX. If our JSX won't properly transform, then we're not really going anywhere. This is a pretty basic task, but there are a couple of gotchas that can really leave you out high and dry due to their nondescript errors. Once we get that down, we're going to define our components with React.create class. Inside of create class, this is the first place we'll get to take a look at JSX. For those of you who are still a bit weary about writing XML syntax within your JavaScript, I promise it'll feel right soon. Writing JSX is largely relegated to the render method, and this is where the meat of our components take place. Lastly, we'll get our components rendered out to the page by calling React.createComponent. With all this primer, let's dive in. If this is your first time touching React, you'll have to know that we need two script files. The first is just React itself, and the second is the JSX Transformer. Right now we're just going to grab these from the CDN. These files will be available in the links as well as in the source code. Let's start off by creating a script block. To the browser, anything inside of the script block is just going to be regular JavaScript. We're going to have to provide something to let the JSX Transformer know that we're writing JSX here. We do this by including the pragma. The pragma is really just a comment, and this is what links JSX and React together. And it's just a comment, but it's kind of picky. You'll notice that it starts out with 2 asterisks. If we change it to just 1 asterisk in the beginning, this will throw an error. And this error is pretty nondescript and it's kind of frustrating to deal with. So whenever you're writing JSX, really take a look and make sure that your pragma is right before you start pinpointing any other errors. The next thing we need to know for the JSX compiler is to provide a type equals text/JSX. And this is only because we're working with an embedded script block. Now that our JSX will transform properly, let's define our first component. React has a method called createClass, and this is what we're going to use to define our component. We'll keep the first component simple and we'll just create a message box. It's convention to store the return value as a Pascal cased variable here. So we have a capital M for message as well as the capital B for box. You can really do whatever you want, but you'll find that this is the most often thing around the web. All we're doing right here is we're calling React.createClass and storing it into our message box variable. And this defines our component. And notice that I'm using the word define and not render. Defining is just setting up the blueprint. It's like creating a class in Java or C#. Rendering a component is like instantiating a class to create an object. React.createClass just gives us the blueprint. We need to render the blueprint to actually have that tangible copy in the DOM. CreateClass accepts an object literal, and this object literal will contain functions that help us define our component. These functions are mostly things that React expects from us. And for the most part, these are all optional, except for one, and that's the render method. Within the render method, this is where we describe our component's eventual structure in the DOM. This is the function where we get to write our JSX. JSX is a bit different than what you're used to writing, but we're just going to have a simple case for this example. In a later video, we'll go over all the ins and outs of JSX. This render method needs to return a node. Let's create an h1 tag and write out hello world. At this point, this is really all we need to define our message box. It's a little weird returning HTML inside this JavaScript function, but JSX really allows us to do this. Behind the scenes, JSX turns each one of these HTML nodes into a function. Since we said that create class defines the component rather than renders it, what do we think that create class actually returns? Let's pull up the Chrome DevTools and check that out. With the page open, we'll just see everything blank, and that's because nothing is rendered yet. So within the console, let's type in message box. And now we'll hit enter, and our message box variable is just a function. All the definitions are essentially functions that take in some parameters and that renders out a component. There is a consequence from this though. Because all the nodes are returned as functions, there is a limitation that we have to abide by. We can only ever return one root node from the render function. And this is just a limitation of JavaScript. We can only ever return one value from a function. We can't return multiple functions. In this case, if we were to try to return a span or something like that, we would get an error. If you want to return more than one node, you can just simply wrap it in a div. Now we're only returning one root node, but we'll still have an error. And this is because we actually need this div backed up on the same line as the return statement. And this looks a little funky, so there's a bit of a syntactic preference some React developers have. Rather than backing up the element onto the return statement, we can wrap it in parentheses. And this will give us a bit more formatting freedom inside of the render method. Let's bring this back to only returning the h1. Our component is now defined, so let's get it rendered in the DOM. To get our component rendered in the DOM, we'll call react.renderComponent. This function will take in our component as the first parameter. Since we're using JSX, we can just write the tag rather than the variable. And this could be a self-closing tag like this, or it could be an open and close tag. But in this case, it's probably just easy to do the closing tag. The second parameter is an HTML node that will act as a container. All of the contents within this node will be replaced with our React component. In this case, we're just going to use this div with the ID of app. The third and last parameter is optional, and this is a callback function. It'll be fired off whenever our component is finished rendering. While it's good to know this, it's not really that commonly used. So let's save and check it out in the browser. In the browser, we have our hello world component, and we can see in the console that after render logged. Let's go through and inspect this element. And we have an h1 and it says hello world. In this lesson, we were able to create our first component. We learned that we have to use the pragma to get our JSX to properly transform. And this pragma is a little picky, so we have to make sure that we provide these two asterisks at the beginning. Then to define our component, we use react.createClass. This doesn't render it to the DOM, but it does provide a definition. To describe the behavior of the component, we pass an object literal into createClass. This object literal will contain functions. The only required function is the render method. This function describes our eventual structure of our component. One limitation we saw is that we can only return one root node because all components are functions and we can't return multiple values from a function. And lastly, we rendered our component using react.renderComponent. This method takes in our component, the DOM node to insert it into, and an optional callback that isn't really commonly used. The main thing to take away from all of this is that createClass doesn't render the component. It defines it, and it returns to us a function that we can use to create the component. RenderComponent uses that function we get from createClass, and that renders it into the DOM with the provided container node. When it comes to creating components, this is a pretty solid foundation to go off of, but right now JSX may seem pretty cryptic to you. And if you haven't already, you'll finally start to feel at home with writing HTML tags in your JavaScript. If you're coming from another framework like Angular or Ember, then you're used to writing templates. We use templates to structure our views without having to directly manipulate the DOM. This concept doesn't exist in React. Templates are an abstraction on top of HTML, and they give us functionality that currently doesn't exist. In React, everything is just JavaScript. Every node we render starts out as a JavaScript function. To make things read easier, React uses the JSX syntax. JSX allows us to write HTML-like nodes in our JavaScript. Naturally, this can kind of feel weird and perhaps just downright wrong. And if you can't get down with that, then well, there's an alternative. and that's using the React.dom namespace. In this video, we're going to compare using JSX versus React.dom. We'll see that these choices really just boil down to syntax. It's important though to highlight the experience of using them both. Just as a quick review, let's set up our JSX to be transformed via an embedded script block. We'll make sure to remember the type is text/JSX. We also need to remember the pragma. JSX is an independent technology that was made with React in mind. It's actually the pragma that links JSX and React together. This pragma tells JSX to use the React.dom namespace. Theoretically, we could create our own implementation on top of JSX, and we would just need to change the pragma to point to our namespace. Let's create a message box again, but this time we'll use a div as the root node. In React, we can give properties to our nodes just as we would in HTML. And this is where a lot of the power derives from in React, and we'll see how this works in a later video. For now, we'll just add a class of container onto the div. Let's render this component out to the DOM using React.renderComponent. Our message box is rendered in the page, but we see a warning in the console. This warning tells us that we're using an unknown DOM property class, and the only property we were using was the class property. And it also asks us, did you mean class name? If we had a container class written in CSS, we actually wouldn't see it applied. This is one of the main gotchas that new React users come across. We have to remember that React is still just JavaScript, so keywords like class are reserved. To get around this, we'll do what the warning suggests, and we'll change it from class to class name. Back in the code, we'll change this to class name, and now if we save, we no longer see this warning in the console. Keep this in mind as you're writing properties. We can't use any reserved keywords in JavaScript. Since our components will render out the HTML, it makes sense that we can use them together as either parent-child or sibling nodes. Let's create a submessage component that's just a small tag. It'll just print out a simple message. Now with our submessage defined, let's add it to our message box as a child. And that's simply all we have to do to combine components. We don't need to do any modifications to our render component method either. It knows how to render out this submessage. And we can see that it works in the browser. We mentioned before that JSX is just syntactic sugar for React. But what part does JSX actually make sweeter? JSX allows us to write HTML-like syntax for the HTML and React components we create. Without JSX, we have to create all these HTML nodes with the React.dom namespace. The React.dom namespace is just a set of functions that represent HTML nodes. We can call these functions in our render method just as we were to create tags in using JSX. And what's the difference between these two? Really, it's just the syntax. Let's create the same message box using React.dom. Inside of the render function, we're not using our tags. We're calling on the React.dom namespace and then calling the h1 function. And just as you would expect, this returns an h1 node. The first parameter are the properties. Right now we're not passing any, so we'll throw null. The second is the text, and we'll just pass hello world for now. Let's render this message box out to the DOM. In this case, we need to call the message box DOM variable as a function, since we're not using JSX. Below our JSX component, we have our React.dom rendered out to the page. That's how you create a single node component with React.dom. How do we nest these nodes like we're doing above? What you'll notice right now is that the h1 takes in two parameters. We talked about before how the h1 function takes in two parameters. The first one is the properties, and we can specify that through an object literal. If there are no properties, we can just pass in null. The next is the text to display. There's one more we can add though. The third parameter is an argument array of child nodes. So we don't pass in an array, we can just continue to pass in arguments like an argument array. These child nodes have to be called as a function. They too can contain the same parameters that we just mentioned, so we can infinitely nest components. Let's go and write the same structure as the JSX is using above. Now that we have to return the function in the render method, it makes sense why we can't return more than one node when we're using JSX. It's not possible to return multiple values. One other thing we notice is that we're using the submessage component as a function here. At the end of the day, whether you're using JSX or React.dom, it's all just JavaScript, so we can interchange both. JSX is just the sugar on top of React.dom. Just take a look at the pragma. That's why we're providing React.dom when we're setting it up. Now in the browser, we see the two identical looking components. In this lesson, we learned about the basics of JSX. We learned that JSX is just sugar on top of React.dom. So we can't use keywords like class or for. To use multiple components with JSX, it's just as easy as nesting that component's tag. Since JSX is just the syntactic sugar for using the React.dom namespace, if we don't want to use JSX, we can just call the functions that define the nodes within React.dom. With React.dom, we can call the function from the namespace that represents the HTML node. By now you probably have a good idea of whether you want to use React.dom or JSX. But if you're still deciding, the bottom line is this really just comes down to your preference. By using React.dom, we lose out on the succinctness of our render method. It's a bit bulky using React.dom, and it's hard to visualize what our structure will be. JSX is easy to follow along, because visually, it looks similar to the HTML that we'll end up rendering. Personally, I prefer using JSX, and most of the community does too. For the rest of the course, this is the preferred method that we're going to use. But if you want to use React.dom, you can easily do that as well. At this point, we have a good idea of what it takes to create components with either JSX or React.dom, but our components aren't really doing anything. There's no real difference between just writing the HTML at this point. In the next lesson, we're going to learn how we can use declarative properties and state to give our components more functionality. Hey everyone, in this lesson we're going to define our component hierarchy and create a static version of our project in React. The goal of this app is to display a feed of news items that can be voted on. We'll also provide the ability to create a new item in the feed. This is the static version in HTML. Before we write any React code, we need to take a look at our UI and see what components we can break down from it. The smallest component here is probably the news feed item, and this belongs inside of a feed list. Above this list, we have a form to submit new feed items. This should require a button that toggles whether the form should be shown. So let's mock this up in a comment. We know that the smallest item is the feed item, and the feed item is owned by the feed list. And we also have a way to create feed items with the feed form. And to show and toggle the feed form, we'll have this show add button. These components are all on the same level, so they don't have a top level component to hold the state. So in this case, where does the state get held? In these cases, we can create a top level component just to hold the state, and we'll call this component feed. This is the mock view of our React components. So from here we can create all of our component files. And by looking at the structure, we'll know what we need to require for our dependencies. So inside of our components folder, let's start adding files. We'll add feed.js. We'll add show add button, as well as the feed form. We'll have the feed list, and then the individual feed item. And since we have this all set up as HTML, we can actually just return this from our render function. We'll have to change class to say class name, but this will render out a static version. Right here, I'm going to use a snippet to create a component, and we'll call this feed item. Now within our render function, let's copy our HTML, and that's this list item right here. We'll change all the instances to class name. Now that that's done, let's do the same for feed list. We'll use the snippet again, and we'll copy in this unordered list, and we know that this feed list will take in the feed item. And we'll want to render out multiple feed items. So we'll assume right now that we're getting them as props. And we'll just pass the title and description for now. And we'll add these inside our unordered list. Now let's add the HTML for our feed form. And next we'll grab the show add button. And lastly, we'll set all this up in our feed. We'll wrap everything in a div, and we'll start with our show hide button. We'll place that inside of a container. And below this, we'll do the feed form. And below that, we'll do the feed list. Now let's set some feed items to our initial state. We're just populating it right now with some dummy data. We'll pass our feed to the feed list. Now we'll set the rendering inside of main.js. To get our feed, we need to require it. And we know that's in .components/feed. Now we'll go into our static HTML and we'll get rid of all this. The only thing that we'll leave is our Jumbotron, our mock structure, and this container node. And now let's reference our script file. And this is the distribution folder, js/main.js. If you were running gulp serve as this was running, it should have built out the distribution folder for you. But if you weren't, just run gulp serve now. When the page loads, we see that the show add button is not defined. So we'll click on that, and we can see that it's inside of our feed. And right here inside of our feed, all that we're requiring is React. So let's go and require our other components. We'll do our show add button, our feed form, and our feed list. With all of our dependencies required, let's check it out in the browser. In the browser, we have our stuff showing up, but there's a couple issues. Our container is kind of messed up here, and we're not displaying our props for our feed item. In our feed list, we can add another class to our class name, and we'll set this to container. Now in our feed item, rather than hard coding these names in, let's set the properties. And in our feed list, we'll have to make sure we're passing in vote count as well. Now back on our page, this looks just like our HTML static version, except in this case, it's all mocked up in React. In this lesson, we looked at our static HTML and we broke it down into a hierarchy of React components. From there, we were able to add them into separate files. We knew what the dependencies were because of the way we did our mock structure. Now that we have the static version, let's add the functionality to add a new story and change the votes. Hey everyone, in this lesson we're going to talk about making our components composable by using props. We learned in the last lesson that every time state changes, it re-renders our component. One thing to keep in mind though is it doesn't just re-render the one component. It also causes all of our child components to be re-rendered as well. As inefficient as this may sound, we have to remember that because of the virtual DOM, only a difference is re-rendered. Since the component and all the child components re-render, we pass our state from only a top-level component. From this top-level component, we push that state data down to all of our child components. This way we only have to deal with it in one spot. The way we pass the data to our child components is through props. Props are really simple to use. We just pass them through as attributes when using JSX. This gives us a declarative style way of composing our components. Down at the bottom where we're rendering our component, we can create a variable and we'll just call it message. Inside of the message box tab, we'll create a property. We'll call it title message and we'll set it to the message variable. Now in our message box where we have hello world, we'll change this. We'll create an expression and inside of it we'll type this.props.titleMessage. This is very similar to the way we got our data from state. We see we have our component with yo rendered. And in the command line, if we type React component, then we can tap into props. This returns us an object that has a property of title message, so we know we set our props correctly. In our last lesson, we also learned that to set state, we should never access this.state directly. Rather, we should use setState. Props have a similar behavior. We should never call out to this.props to change anything, which means they can't change. For props to change, the component will have to re-render. This fits right into making our state manageable. We don't have to worry about storing state at multiple component levels. We only have it stored in one top-level component. We don't have to worry about storing the state of a child component or updating a bunch of small things in our view. Once a change is made, we re-render with our new state. The structure to realize here is that state is stored at a top-level component. When the state changes, it gets pushed down to the child components via props. Props are immutable and they can't change. If we want our props to update, state will have to change. And this just makes our components like state machines. Given a new state, they re-render out with their properties. And their properties can't change, because if we were changing these little properties, it would defeat the whole purpose of this nice re-rendering model. The difference between props and state is one of the most confusing things when beginning with React, so don't worry if it's a bit confusing at first. The more we go along, the easier it'll seem. In React, we can set default values for our props. Let's remove the prop off the top level component. In the submessage component, let's define the getDefaultProps function. Within here, we can return an object literal that represents our props. We'll call this one message, and we'll just give it a default one if it's good to see you. Now inside render, we can change this to use an expression. And we'll just call into this.props.message. And since we're no longer using the title message for props, let's change it back to hello world. And we can see that we have the it's good to see you printed out. Let's go and change this at the top level component. Usually we'd want to set our prop based off of something from our state. In this case, we'll just stub out a variable. We'll create a variable called submessage, and we'll set its value to it's not good to see you. Now in our submessage, we'll set the message prop to our message. And this changed to it's not good to see you. Now our submessage is composable. Whenever we pass a message through the property, we can render out a new message into it. And this is a basic example, but it does give us a reusability for this component. It's important to understand the relationship between the message box and the submessage component. We're familiar with the parent-child relationship, but there's also another relationship here that's specific to React. The message box is the owner of the submessage component. The React docs state that in React, an owner is a component that sets the props of other components. In this case, our message box is setting the props for the submessage. Therefore, it's the owner of our submessage. Another useful feature of props is the way that they can be validated. We can state what type the prop should be or whether it even should be required. And we can set that within our component using the prop types property. Let's take our message and let's make sure that it's a string and that it's required. We can tap into the React namespace, then call prop types. Now type .string. At this point, it'll make sure that it's a string, but it doesn't do anything to make sure that it's required. To do that, we can now type is required. This is the way it works for string, but it also works for the same for Boolean, number, and a bunch of other data types. There's even more advanced validation techniques out there, and you can check out the React docs for more information, and there's a link provided in the source. Now we're making sure that this prop is the type of string and it's required. If we don't supply a string though, we won't get an error. Up here, let's change our submessage to null. And also this needs to be a property instead of a function. In the console, we can see a couple of warnings. One lets us know that we need to precompile our JSX when we're in production, and we'll learn about that later. The one to focus on right here is the fact that it says required prop message was not specified in the submessage. And this is because we were providing the null value. But there wasn't an error, it just provides us with a warning. This won't break any functionality, but it will help us understand why some of the things may not be working in our app. Rather than going back and setting our submessage variable to a string, let's do something a bit more useful. Rather than keeping track of one submessage, let's keep track of multiple submessages. So this will require dynamically creating subcomponents. And we can do this through our state. We said before that the props can be set from a top-level component state. With this in mind, let's create an array of messages as our initial state. In our getInitialState function, let's create a messages property. Inside of here, I'm going to paste in an array. And this is just a list of a couple of messages. Now the goal is we want to create a submessage component for each one of these items in the array. For each one of these components, we'll pass the item as a property, therefore composing each separate component. In this case, we'll use JavaScript's map function to return a new array of items. This will iterate through each one of the messages and states and return a new array from it. What this array will contain will be determined by what we return inside of this callback function. In this case, we'll return our submessage with our message prop, and we'll set our message to the message that's being passed back in the callback. Now that we're storing this in a variable, we can set it into our JSX using an expression. We'll get rid of this one component, and now we'll add our messages. And to the left, we can see all of our properties are dynamically created in a list. Let's tap into our React component to add a new item. What we can do is we can create an array from our current state. Let's add a new item to the messages in our state. To do that, we're going to call setState. But first, we need to create a new array based upon our initial array. We'll tap into the React components.state and return the array, add the new item, then call setState. And we'll do this through the concat method. Now let's log our new messages array. At the end, we can see our new item has been added. So let's take this and let's set it as the state. And when we add that, we can see our new item gets rendered. In this lesson, we learned that props give our components composability. And this makes our component act like a function. When we pass a new property through, we'll get a different component. We also learned that we want to set our state at a top-level component. From there, we can take that state and pass it down to our children from their props. And this makes it easier for us to reason about our application state. We're not going to re-render smaller parts of our app. We're going to change the state once and re-render the entire thing. And we don't have to worry about performance because of React's virtual DOM. We also learned that in React, an owner is the component that sets the props of other components. In this case, it was our message box setting the prop of our submessage. And with props, we can even do validation through prop types. We can check to make sure that our prop is a certain type, or that it even needs to be required. And keep in mind, if the validation isn't fulfilled, we won't break any functionality, it'll just give us a warning. We also learned how we can create dynamic components by just using native functions within JavaScript. We had an array of messages, and using the map function, we were able to turn a new array, which returned to us our composed submessages. From there, we just rendered that into our JSX, which is a lot more expressive than using templates. It's important to take a second here to realize how this is different than the regular templating approach we've done with other frameworks. In other frameworks templating, we're using their domain-specific language, whatever their template format is. And given that, we usually use some type of for each operator. And usually that's one of the only few ways that we can iterate through a list of items. However, in React, it's a lot easier and a lot more expressive, because we're just doing everything in JavaScript. In this case, we're using the map function to return a new set of components that we're composing. And this is one of the benefits of using React. Now we know a bit about using props in our components, but we haven't encountered anything so far about directly accessing any elements. What if we want to get the value from a text box? How would we go about doing that? And we can do that with refs. Hey everyone, in this lesson we're going to learn how React handles events. In our ongoing example, let's give the user the ability to add a new message to the list. And we're going to need a button for that. Let's add one and let's set the onClick event for it. Right above the messages, we'll add a new button. And now we're going to add the onClick event, and we're going to do it with a camel casing. Using an expression, we're going to set it to a function that we haven't created yet, and we'll call it this.handleAdd. One thing to know is that this onClick property is not the same onClick that we're used to seeing within an HTML element. They look similar, but they act different. This onClick with the camel case is what React uses. This camel casing is the standard for all event types. We can do the same for mouse up and key up and really all the other events that we'd expect to see as well. Now let's go and implement the handleAdd event handler. We can do this above our initial state. And since this is an event handler, it's going to return an event. So let's log this event to the console. And let's make sure that rather than class, it's class name. Now when we click, we don't see a regular event. The type we see returned is a synthetic event. This isn't the actual event, but it acts like it. This synthetic event is guaranteed to be consistent to the W3C standard across all browsers. If we drill into this object, you'll notice something kind of weird. We see a lot of null values for all the properties. But this is just a quirk in React. React reuses all the event objects for performance. So these values are null by the time the log is buffered. We can still access things such as our target. So now rather than logging the event, let's log the target. And after we click add, we don't see the synthetic event anymore. We see the actual target that was clicked. When we're dealing with callbacks in JavaScript, it can be really annoying dealing with this. In one function, we have this referring to what we want, but as soon as we drill into that callback, this suddenly changes to something else. And usually it's something not useful, such as the window. React handles this for us by auto-binding the this context to the React component, because usually the React component is what we're looking for. Let's check this out by logging this to the console. Now when the button is clicked, we should see the React component logged out to the console. Now when we click add, we get our component logged out to the console. Another great feature of React is how it handles event delegation. Just because we're declaring the onClick event on the button doesn't mean it's actually attached to that button. React stores all event handlers at a top-level node. At this node, React creates mappings for this handler that knows how to dispatch the event. And this is much more efficient than creating multiple event handlers on each and every little node. Event delegation isn't anything that's new, and it's something that you usually keep in mind when you're interacting with the DOM. So it's great in this case that React really handles this for us. So what to take away from this is that React doesn't use real events, it uses synthetic events. These events are consistent with the W3C standard, meaning that we get consistent behavior across all the browsers. Also, when we create a callback for these handlers, React auto-combines the component as the this keyword. And as far as event delegation goes, React handles this for us out of the box. React does this by mapping events to a top-level node and dispatching them when needed. With this click event handled, we want to be able to post a new message when it's clicked. To do this, we're going to need to add a text box. The question here, though, is how do we tap into this text box? How do we grab its value? In this case, we need to talk to this DOM node to pull out the value. But currently, we don't have any way to do that. These components are just blueprints. They're not actual DOM nodes. And our render method returns the component, not the actual DOM node itself. Fortunately, we can do this with refs. So in the next lesson, we're going to go over refs and we're going to get this new message added to the list. Hey everyone, in this lesson, we're going to talk about how we can access our DOM nodes using refs. So far in this course, we've covered rendering our components based on our state. We store that state at a top-level component. We pass it down to our child components using props. And this will create the blueprint for rendering out our components. But we don't actually know how to access the DOM nodes within these components. And in this case, we need to get the text value from this text box. So to access our DOM nodes, we're going to use refs. We know when we use React.createClass is that we're not actually creating the real markup. We know we're just creating a blueprint. This means that we can't just go and store our component to a variable. And also this component is a function. It's not the actual markup. Every time this component renders, we're going to have new nodes. So we're going to need a way to get into the backing node. So rather than storing this into variables, we're going to use the ref property. In our text box, we're going to define the ref property. All it is just ref equals and then the name of our ref. In this case, we'll call it new message. And the way we'd access this is through this.refs.newMessage. Let's comment this out for now and let's check it out in the browser. We'll call on our React component and now we'll call it .refs. And what refs returns to us is an object and one of the keys is our new message ref. And when we open it up, we see that it's also a component, which is just like our root level React component. If we tap into that ref again, we call .refs and then .newMessage. There's a function we can call called getDOMNode. And when we call this function, it returns back that DOM node that we attach the ref to. In this case, it returns to us our text box. So by using the getDOMNode function, we can access the real DOM node. And we'll be able to use this to get the value from the text box. Inside of our event handler, we can store this into a variable. And then on this.refs.newMessage, we'll call getDomNode, and then we can call value. When our button is clicked, it'll grab the value from that DOM node and store it into this variable. And this text box is a good scenario of when we'd want to use refs. Usually we don't have to place refs on our nodes. However, in cases where we need to extract a value from the DOM, this is where refs come into play. So think about form elements such as a radio button or a text box. These are usually the best candidates for refs. So when we need to extract values from the DOM, refs are the tool to use. Now that we have this message, let's add it to our state. So what might be a bit difficult here is the fact that we're just adding one item to our state, and we don't access state directly. So we can't do something like this.state.push, because we should only access state through setState. So in this case, let's create a new array based upon our state array. And we could just call new messages.push. But a more convenient way would actually be using concat. And concat will add two arrays together. So we can pass these square brackets in, and we can provide our new message. Now we can call setState, and we'll pass through our new messages array. So just to recap, down here we have this button. When the button gets clicked, it's going to call this handle add function. Up here, we're going to get a new message by extracting the value from the DOM node. And we got this by placing a ref on this text box. Then we're going to add this new message to our state. But since we can't mutate our state, we need to create a new array based off of our given state. And we do this by calling the concat function on our state. And it's fine to do this because concat doesn't add anything to our state, it just creates a new array based on our state with the new message added to it. Then we call setState with this new array, and it re-renders with our new item added. And before we check this out, let's make sure to call this messages. So now let's go and add some gibberish. And when we click add, we get our new item rendered. In this lesson, we covered refs. In React, the DOM keeps re-rendering. This makes it complicated to get access to a single node. Our components are just blueprints, so to access the nodes, we need to use the ref property. When we access the ref property, we just get back a React component. From there, we can call the getDomNode function to get the actual DOM node back. We want to use refs in the cases where we need to extract data from the DOM. And a great example of this was our text box. Now this example was really simple because we were working with the component that holds state. Our message box holds the message, and our button was within the message box. So when we click that, it's easy just to access the state. What if the submessage actually held the text box? We can't call setState in a child component because they just use props, which are immutable. So how do we change state and trigger a re-render? In the next lesson, we're going to talk about how we'd want to structure our components. We'll talk about using a one-way directional flow of data from a top component down to the child components, but using a callback to update state from a child component. Hey everyone, in this lesson we're going to go over how we should structure the flow of our data through our components. In our previous lesson, we set up a handler to add a new message to our state. This was easy because our handler was on the same component that held the state. What if we wanted to set up a button that deleted individual messages? This button would have to be on the submessage component, and this component doesn't have access to state. It doesn't have access because we want to store state at the top level component. The reasoning behind this is we want to establish a one-way directional flow of data. In our getInitialState function, we have our messages array. In our render method, we're creating a list of message components by composing them with the message property. This submessage component doesn't use state. It relies off of the props that were passed through to it from its owner. Since this component doesn't store state, we can't call setState and expect a proper re-render. We don't want to call setState on an owned component anyways. When we call setState, it triggers the reconciliation process. This is the process where we create a new virtual DOM node, we diff it against the current one, and we only render out the differences. If we store state in our own components, we start making things more complicated. Our components are supposed to be state machines. We're not dealing with little small mutations in our state. We don't want to handle our state in small pieces. We want one big re-render. Components are just functions that take in props and state, and based on those props and state, we can render new elements. If our state changes, then we just re-render again. We're not going to modify individual elements. We want to do this from the top all the way down. This setup is really simple. State can only be messed with at the top level component, and that component knows how to compose all the child or owned components through their props. So if we can't modify state in a child component, how do we access it? Well, we don't want to directly access the state, but we can send a message using a callback. Props allow us to send data down to our owned components. In this case, we're sending down a message, but we also could send down a function that knows how to call back to our root component, and whatever we pass through as the parameter will allow us to update state. Let's demonstrate this by adding the delete button. In our submessage component, we'll create a button and attach an onClick handler. We'll set the click handler to this.handleDelete. Within this event handler, we still can't directly access our state, and we know that this is a good thing. Any changes that happen to state need to happen at the topmost level, and we know that this top level component will send down our state to our child components through props. So if our top level component sends down data through props, we also could send a callback function down as props, and that callback function would be defined in the top level component. When we call it in the child or owned component, it'll be able to set state of the top level component. So let's wire up this callback function. Where we're mapping all of our messages, we'll attach this callback property, and we'll call it onDelete. We'll set it to this.deleteMessage. Now we can wire up this function inside of our own component, since it's passed down through as a prop. We can see this by logging the props. Our message is I like the world, and we have an onDelete function that's undefined. But it shouldn't be undefined because we're setting it, so let's take a look and see why it's undefined. Inside of our map function, we can see that onDelete is being set to this.deleteMessage, and this delete message function is defined up here. So why is it returning undefined? Well, this is because the context of the this keyword inside of the map function. We want the context to be the component. If we log this to the console, the browser lets us know that it's the window, and we don't want it to be the window, we want it to be the component. To change the context of this, we can bind it. So at the end of this function, we can call .bind, and what we'll pass through is this, because in this context, the this keyword is the component, which knows how to call delete message. So all bind does is it changes the context of this inside of this callback function. In the console, we see that we have the component, and if we click delete, we see that our onDelete property is populated with the function. Down in our submessage, let's call our callback function, and we'll pass it our message. Now when we click the button, we get logged to the console deleting, and this is because we're defining that in our callback function. So now rather than just logging something to the console, let's actually make it delete the message. This delete message is going to return us the message we want to delete. What we want to do in this function is we want to remove this item from the array. And since we can't modify this .state, we want to return a copy of the array. To make this easier, we're going to use Lodash. For those of you who aren't familiar with Lodash, it's a utility library. Lodash gives us a lot of useful methods. A good portion of them allow us to do advanced iterations on our array, and all of Lodash's functions return back a copy of the array, so it's perfect for what we're trying to do within React. I'm going to include Lodash from a CDN. This will be available in the source code as well as in the description. So now we want to create the new messages array. And this new messages array will be the same as our state array except for the one item that we're trying to remove. And we can do that through Lodash's without function. The way we access Lodash is through an underscore. And then from here we can call .without. The first parameter is our array, so we'll call this .state.messages. The second parameter is the item we want to remove, so we'll pass in our message. And this will return a new array with all of the items except for the one we want to remove. When we click on the first one, we get an array back, but it doesn't contain the I like the world message. And the same will work for the rest of these. Now we have an array without the removed item, so let's set that to state. So now let's go and delete the top one, and we see it gets removed, and the same will work for the rest. In this lesson, we talked about setting up the one-way directional flow of data. This is done by setting state at the topmost level and passing it down to our owned components via props. To update state from an owned component, we can set a property to a callback function that's being passed through by the owner component. The owned component can call this callback function, and that'll fire off the method that will change our state and trigger the re-render. It's important to know that this doesn't break our one-way directional flow of data. The data still flows downward. The callback function just sends a message to our top-level component and lets it know to re-render and trigger our one-way directional flow of data again. For those of you who are familiar with two-way data binding, you'll notice that this method is quite different. Two-way data binding directly updates a single element whenever its value has changed. In React, we do this differently because we re-render everything when something is changed. Now, React doesn't use two-way data binding, but using these callback functions we learned in this lesson, we can mimic this functionality. So in the next lesson, we'll learn how we can wire these up to mimic two-way data binding. Hey everyone, in this lesson we're going to take a look at React's view on two-way data binding. And mostly we're going to talk about why two-way data binding is a non-feature in React. A lot of modern frameworks hinge on two-way data binding. And two-way data binding is just the automatic synchronization between the model and the view. Every time data is updated in the view, it automatically syncs back to the model or vice versa. Take this Angular app for example. It's just one text box, but whenever it's updated, it updates in the adjacent span. The code for it is just right here. There are two parts for it. We have the controller, and this sets the state to this scope object. Anything in the scope object will be able to be rendered in our view, and our view is represented by this template. Our template is annotated by these ng attributes and these double curly braces. Now, two-way data binding is really convenient for processing forms and doing other heavy input tasks. And this is because we don't have to grab every element on the page using document.getElementById or some jQuery selector. And as convenient as this is, things can get a little hairy when you're dealing with a computed property. A computed property is a property that is calculated by one or more dependent properties. This Angular app is only slightly more complicated than the one previous, but it illustrates what a computed property is. We have these two payment text boxes, and when we enter a number into one, it starts calculating the total in this span. The code for this is a bit more complicated than before. Now we have to watch for each field, and whenever that field is updated, we have to recalculate the value. And this value is bound to the span. This isn't like React. In React, we can change our state in one place and re-render our component based on that new state. This Angular app is updating each individual element based on its binding. If you look down right here in our scope object, we're calling scope.watch twice, because we have to watch on each property. Now this is a simple example, but could you imagine if we had a large array of items to deal with? It becomes hard to determine what is changing the state in our application. We'd have a lot more text boxes than this, and when they're update, our total would update, and we wouldn't know which text box exactly is updating it. And this is because our state is spread out through the entire application. In React, we manage our state in one place, and we pass that down to all of our components via props. We aren't tracking each individual change and updating every individual element. Props are immutable, so we can't change them unless we re-render. So let's see how this would work in React. We'll create an app component and set its initial state to 0. Now we'll go and write our render function. Inside of this render function, we're going to render out a div as our root node. We'll put in a text box as well as our state property. To update this state, we'd have to put an onChange handler on the text box as well as a ref. In that handler, we'd have to set state and then re-render. And this is simple, but it's a bit tedious to have to wire that up every time. There's a shortcut in React that makes this a bit easier, and that's called React Link. There's a version of React we can grab from the CDN that gives us a couple add-ons, and this is just called React with add-ons. Up here after this dash, we can say dash with dash add-ons. One of the things this add-ons version gives us is a mixin called React Link, and a mixin is just a piece of reusable code that can be dropped into any component. Up here, we'll set our mixins property, and we include those in an array. And our mixin is called react.addons.linkedStateMixin. Now, rather than setting the onChange event, we can directly link this text box to the payment property and state using React Link. In this text box, we're going to give it a property called valueLink, And then we're going to set it to this dot link state, and we'll pass through in a string our property name. Now let's render our component. Now when we type, it updates the field just as if it was two-way data binding. However, we know that there is no binding going on here. Whenever the text box changes, the payment property is being updated on state, and this is triggering a re-render. There's no binding, just re-rendering. Let's add another text box and calculate the total. We'll break our text box into another component to get some reusability here. We'll just call this payment. Let's add another field to our state called payment2. We'll return 2 payments inside of this div to display the total. We can use React link here to link these payments to their state properties. We're setting value link in the root node because our root node holds the state. Inside of the payment component, we'll use a shortcut to set our props called transfer props to. This is just a convenience, but it's still good to explicitly state the props when you can. Use this only in situations with dynamic props or simple situations like this. Now to calculate the total, all we have to do is add our 2 state properties together. Now when we add here, we can see the update. There's no bindings, no computed properties, all we're doing is re-rendering. In this lesson, we compare data binding in Angular to re-rendering in React. Data binding synchronizes our HTML and our model. When one updates, the other updates as well. This is convenient until we have to deal with computed properties. It becomes confusing to reason why our property is updating because we have to track all of our dependencies. In React, this process is simplified by re-rendering when updates occur. Usually we'd update our state through a callback, but using React link, we can link a state variable to a node and update on any changes. It can feel a bit more verbose doing it this way in React, but the way we manage our state is much easier to understand. Now we have a good feel for how components work. But before we really feel like we've mastered them, we need to understand the component lifecycle. In the next section, we're going to go over each step of the component lifecycle and all the important functions to know. Hey everyone, in this lesson we're going to begin to cover the React component lifecycle. The component lifecycle may sound complicated, but it's really easy. There are just 3 parts to it. There's mounting, updating, and unmounting. In this lesson, we're going to cover the mounting phase. The mounting phase offers us 2 functions where we can hook into right before and after the initial rendering of the component. In this example, we have a dashboard component. It has an initial state of a metric variable. Its initial state is a metric property that's set to 0. If we want to hook into before the component renders, we'll use the function componentWillMount. Let's set a breakpoint here programmatically to see it in action. This will stop the execution of our code so we can prove that the function executes before the component renders. Now with our console open, let's refresh the page. Right here we don't have anything rendered. Now once we step through, it gets rendered out to the page. This method can be used to do any checks on a component before it renders to the page. We don't have access to the DOM here though, because it hasn't been rendered. Now if we need to hook into the component immediately after it renders, we'll call componentDidMount. Let's drop a debugger in here too. The first debugger hits before rendering. Now the second, it hits after we've rendered. Because this function fires off right after this component renders, we have access to the DOM through this .getDOM node. However, what this function is primarily used for is to set up any initial request to load in the state. To do some quick AJAX loading, we'll use jQuery as well as the Firebase API. Right here we have jQuery included, and we just need to get a Firebase API endpoint. For those of you who don't know what Firebase is, it's a platform for making real-time apps. Firebase allows us to store data in a NoSQL JSON-based data store. Every Firebase can be accessed through a RESTful API. This URL gives us access to a demo Firebase, which isn't secured, so you'll be able to use this too. The URL right here is the base endpoint we're going to be using. Let's load in our data using jQuery's getAjax function. I've pasted in our root Firebase API, and what we can do right here is we can add this.props.url, and we'll make sure to append .json at the end so it returns as JSON. Now rather than providing a callback function here, we actually can just return, because jQuery AJAX functions return a promise. And promises make it a bit easier to deal with asynchronous calls. Now in this function we can call this .loadData, and now we can type in .then, and this will give us a function, and inside of this function it'll be called with our data. Within here we can set our state, and we'll set our metric to our new data. And we want to make sure that we're binding the context of this function to our this keyword, because if we don't, it'll be bound to another context inside of this callback function. Now down here at the bottom where our dashboard component is being rendered, we can provide a prop for our URL. And right now we'll just set it to a URL called metric. And what this does is it links out to this metric property, which is 45. Now when we refresh, we'll hit the first breakpoint, then we'll move to the second, and now we can see that 45 has been rendered. In this lesson, we learned about the mounting phase of the component lifecycle. The mounting phase is where we can hook into a component right before and after it renders. The component willMount function gives us the opportunity to do any checks or logic before the component renders. The component didMount function fires off right after the component has rendered. In this function, we can set up requests to pull in our data. All these functions help us get set up. The next phase will help us when updates start occurring. Hey everyone, in this lesson we're going to continue covering the React component lifecycle by moving on to the updating phase. In the previous lesson we went over the mounting phase, which is the first of 3. The second is the updating phase. There are a few functions we could cover here, but we'll only focus on 2. The first will allow us to check our props, and the second will allow us to determine whether a component should update. When a component is about to get its props set, the component will receive props function fires off. This function takes in a parameter called nextProps. These parameters will be filled with our new properties. We'll still have access to our old properties with this.props. This function won't be fired off on the initial render, and that's because in the initial render we don't have any new properties yet. This is a place where we can check old props against the new ones, and we can possibly set something of interest to state. We'll create a variable called lastURL, and we'll set it to this.props.url. We'll add in a debugger and we'll check this out in the console. Now when we load the page, we don't hit the breakpoint. We know this because component will receive props doesn't fire off the first time a render occurs. To hit this function, we'll have to change the props. In the console, we'll grab our dash component and we'll call setProps. And we'll change the URL, and we'll just set it to a bogus URL at this point. Now when we fire this off, we hit our breakpoint. And what we can see in our object right here is we have a URL of our URL, and that's because it's our new props. If we go into our last URL, it's our old URL called metric. What we can do with this is we actually can change the data that's being loaded. So rather than just loading one metric, let's actually load multiple metrics. Inside of component role props, let's load in our data. We can call this.loadData, and then we can actually call our loadData function with a URL. So we'll provide last URL inside of here, and then we'll call then since it returns a promise. Within here we'll call setState, and we'll set the metric to the data. And this is similar to what we're doing above, so we could abstract this out into its own function. But for now, we'll just leave it like this. And we'll actually have another property here, and we'll call it lastRoute, and we'll set this to the last URL variable. And inside of our render method, we'll set a little area to render out our last URL. We'll set an initial default for it so we don't hit any errors. Now the first time we load, we don't see our last route because we haven't compared against anything yet. Now in the console, if we change our URL to metric2, we get a type error. So let's click on the stack trace right here, and we can see it's from this.setState. And that's because we forgot to bind this to the this keyword. So now right here, we'll bind to this. One thing I'm noticing right here is we're loading our data from the last URL. We actually want to load it from the next URL. Now back in the console, if we change our property again, it loads in metric, and we can see we get our new metric of 145. That's because up here in Firebase, we have metric for 45 and metric 2 of 145. And each one of these maps out to those URLs. The benefit of using React is to render everything on a change, and to let the virtual DOM worry about the performance. However, if you're dealing with a lot of nodes, it might be best to try to tune the performance. The should component update function allows us to decide whether the component should be re-rendered. Let's say we're dealing with a lot of nodes here, and we want to speed up performance. We can check to see if a metric is above 100, and only render out in that case. This function also takes in next properties as well as next state. Using this next state variable, we can check to see if the next metric is greater than 100. This function needs to return a boolean. If we don't, we'll see a warning in the console. In this case, we can return nextState.metric and check to see if it's greater than 100. Now back in the console, we can see that we actually get a 0 here, and that's because it's our default state, because our 45 isn't greater than 100. So let's change our props to metric 2, and that loads out. We can go back to metric again, and we don't see it get loaded. It stays at our 145. In this lesson, we covered the updating phase. The updating phase is the second of the 3 lifecycle phases. In this phase, we can fire off functions that can compare our old properties with our new ones. In the component will receive props function, we can get our new props and we can check them against our old ones. In this case, we're loading in new data when our props change. We also can control whether a component can re-render with the should component update function. This also provides us with our next state, so we can check to see if our next state metric is greater than 100, and if it's not, we won't re-render. At this point, we've covered 2 of the 3 phases. We covered the mounting phase, which sets everything up, and we've now just covered the updating phase that covers any updates that happen with re-rendering. In the next lesson, we'll cover the last phase, which will allow us to do any cleanup when our component gets unmounted. Hey everyone, in this lesson we're going to go over the unmounting phase, which is the last of 3 of the React component lifecycle. In the first 3 phases, we covered how to use the mounting phase to set up our component, and the updating phase, which helps us do any checks or rendering whenever updates occur. And the unmounting phase allows us to do cleanup when we remove the component from the DOM. In this project, I've included the bootstrap JavaScript from the CDN. Let's go down inside of our render function and let's create something to give us a tooltip. Let's create an anchor tag and give it an ID of tip. We'll set its href to a pound. Then we'll give it a data-toggle of tooltip. Now we'll set its title to hover. In our component will mount function, after we set our data, we can call this jQuery plugin. We'll grab the tip and we'll call .tooltip. Now if we go and hover over this link, we see our tooltip. And this works great, but what if we want to remove this node from the page? When we would do that, we'd have all of our listeners still placed in memory. So we need to release those by destroying the tooltip. And we can do all of our cleanup within the component will unmount function. Inside of here, we'll grab the tip again. We'll call tooltip, but inside of here, we'll call destroy. We'll drop in a debugger so we can see it hit. If we want to unmount this function, we need to call react.unmountComponent@node. And the parameter this takes in is the node where this component is mounted. In this case, it's our app component. So we can call document.getElementById and pass through app. So now when we do this, we hit our breakpoint. And if we continue on, we get it removed from the DOM. And the benefit here is that we are able to clean up our tooltip by calling destroy. In this lesson, we covered the last phase of the React component lifecycle, which is the unmounting phase. The mounting phase is where we can do any cleanup when our component is being removed from the DOM. The function that allows us to hook into this event is the component will unmount function. And to remove the component, we call react.unmountComponent@node. And this doesn't take in the React component, it takes in the HTML node which the component is mounted at. And when we fire that off, we'll call the component will unmount function and we can do all of our cleanup. At this point in the course, we've done all of our rendering inside of this script tag. So in the next lesson, we're going to take a look at some build processes for our JSX transform. Hey everyone, in this lesson we're going to transform our JSX to JS using the React Tools npm package. So far, we've been doing all of our JSX transforming in the browser, using the JSX Transformer. This is fine for development and testing around, but it's really not great for a production environment. There's an npm package available that's called React Tools. It provides us with a way to transform our JSX from the command line. We also can provide a watch argument to transform every time that we save. To install React Tools, all we have to do is type npm install React Tools into our console. Before we install React Tools, let's actually do an npm init, and we'll create a package of our own. We'll just accept all the defaults for these. Now we'll install React Tools, but at the end we'll do --save-dev, and this will save it to our package.json file. Now we can type the command to transform our JSX. Let's take a look at our folder structure. We have a source folder and a build folder. And this is just code from a previous lesson. And our build folder will contain our app.js for our transform JSX. So to start the transform, we'll type JSX --watch because we want it to change every single time there's a save. We'll grab the files from the source folder and we'll save them into the build folder. We see right here that it built the app module. Inside of our build folder, we can see we have our app.js. And there's no JSX inside here, it's using React.dom. Now if we were going to make a change here, and we'll just hit some spaces, and then we save, in our console we see app.js change rebuilding. And to stop this, we just hit Ctrl+C. This command line option allows us to transform our JSX. But this command requires us to remember it every single time we open up the project. The better option would be to set this command inside the npm start command. Inside our package.json, we see this section called scripts. We're going to add a property called start. And the start command will be our JSX transform. So that's JSX --watch, our source folder to our build folder. Now in the console, when we type npm start, we start watching for our transform. Using React Tools is probably the fastest way to set up your JSX to be transformed. However, it's still on us to manage all of our components. So far, we've written all of our components on one page. This is not the way we do things in a production app. We'll need to break things out into separate files to make our project maintainable. We could use the window to link all these components together, but we're still on the hook for combining all of our files into one. In the next lesson, we're going to take a look at Browserify, and we're going to see how we can use that to easily manage our components and their dependencies. Hey everyone, in this lesson we're going to learn how to use Browserify to manage and bundle our dependencies. In the previous lesson, we used the React Tools npm package to transform our JSX. This worked well for our current situation where we have all of our code on one page. As we create bigger projects, we'll want to have our components in their own files. If we use the transformer, we'll need to add our components to the window to use them in separate files. Now this isn't a terrible solution, but we have a better one with Browserify. Browserify is an npm package that allows us to use Node.js features on the client side. One of the biggest features is the use of the require function. The require function allows us to import a dependency. This is a much cleaner and more obvious way to deal with a dependency than hoping that the object is actually attached to the window. The ideal situation here is that we treat each component as a module. Then we can require all of our child components and our parent components. We'll download the npm package in a bit, but first let's break apart our project into separate files. We'll create two files here, one for the submessage and message box. Now let's move our message box component over, as well as our submessage, and we have to remember to use the pragma as well. Now to use Browserify, we're going to need to require a dependency. But to have that dependency, we have to install it with npm. All of our dependencies can be located in our package.json file. Right now our only dependency is React Tools, and we're not going to use that. We need to install React from npm if we want to use it in Browserify. In the command line, we'll type npm install React and then do --save. Now in our dependencies, we see that we have React. In our submessage, we can require React by saying var React equals require React. And this variable could technically be anything we want it to be, but we're used to calling React with an uppercase on the client, so we'll just stick with that. Now that we've stated our submodule, we have to export it out. To do that, we can say module.exports, and we can set that to our submessage. Now in our message box, we can do the same thing where we're requiring React. And this message box uses the submessage box, so we have to require that as well. However, our submessage module isn't a global dependency like React is, so we have to specify where it is. In this case, it's just in the same folder, so // will suffice. Now down here at the bottom, we'll make sure to export this module, and we'll set that to the message box variable. Within app.js, we need to require React, and right here, all we have to do is require the message box. So we've used Browserify to manage our dependencies, but Browserify itself doesn't transform our JSX. To transform our JSX, we need to use Reactify. Reactify is a Browserify plugin that'll transform our JSX. So let's install Reactify. And when we install Reactify, we don't have to worry about installing Browserify because it's a dependency of Reactify. So we'll do an npm install of Reactify, and we'll make sure to save. And we'll save this to our dev dependencies. And we can see we have Reactify on our package.json. Now we can enter our Browserify statement in the command line, but we know that we should do this inside the npm start command. So let's replace using our JSX right here, and we'll start by calling Browserify. We'll say -t Reactify, and now we'll set up the files that we're reactifying. We'll start with source/app.js, and we'll send that over to build/app.js. And what's important to note here is from source, we only have to build app.js. And this is because Browserify will actually bundle all of our files into one. And we have to make sure we have the greater than sign right here. From the command line, we'll enter npm start. And now in our build folder, our app.js has all these files bundled into one. If we open up the page, we see an error in our console, and it says unexpected token. So if we click on that, we can see our JSX isn't being transformed here, but above it's being transformed here. So let's see what it gives. And the reason is, inside of app.js, we have to remember to use the pragma. Even though we're sending it through Reactify, we still need the pragma to know that we have to transform the file. Let's run npm start again. Now when we refresh the page, we can see our old example. In this lesson, we covered using Browserify to manage and bundle our dependencies. Browserify allows us to use Node.js features on the client side. The one feature we're interested in using is the require function. This allows us to break our components out into modules and require them as dependencies. Browserify itself won't transform our JSX, so we need to use Reactify. And after we've set up Browserify through our npm start command and we build, all of our files get bundled into one main file. Now that we all know about React's build process, let's go and actually build something. In the next section, we're going to build a real-time voting news application. Before we begin making our application, let's provide some context to what we'll actually be building. This app is a real-time news voting app called Vote It. We can vote stories up and down and see the count change. Whenever a story overtakes another story, the list will reorder. And down here at the bottom, if a vote falls below 0, the label will become red. We can submit our news stories up here. And after we've added, it starts with a vote of 0. All of this data will be saved with Firebase. We'll use Firebase's real-time API through their JS library. This way we'll ditch the request response model and get real-time push updates to our app. And we'll learn that this is a process that actually fits React the best. Now that we're ready to build, let's go set up our build process with Gulp. Hey everyone, in this lesson we'll set up our build process using Gulp. For those of you unfamiliar with Gulp, it's a JavaScript task runner. We can do things such as copy and concat files or compile less or Sass to CSS. In this case, we're going to use it for a few things. We're going to use it to set up a local server with live reload, browserify our code, watch and reload for file changes, and launch our app in the browser after building. In the beginning source, you'll find a nearly blank project with this structure. We have our main folder, and underneath that there's an app folder. And underneath that there's a source folder, which has a JavaScript folder, which currently contains a main.js. And also in that same folder is a components folder. And this is where we're going to put all of our components. And one folder you don't see yet, but you will when we build, is we'll have a dist folder. And this stands for distribution. So to get our build process going, let's get started on our gulp file. Before we use gulp though, we need to make sure we have it installed. In this package.json, we have all of our dev dependencies being listed here. In this case, we can just type npm install and it'll go and install all of these dependencies. So now here in the command line, I'll type npm I, which stands for npm install, and it goes through and it pulls down all of our dependencies. Now that that's done, let's check out our gulp file. To start with our gulp file, we need to require our dependencies. Now these require statements up here aren't browserify, they're actual Node.js. And these are all the gulp and the gulp plugins that we're using. Gulp is the main one, connect will be for our server, open will launch our browser, browserify will browserify and reactify our code, and concat will concat any files that we need. Now this isn't a course on gulp, so we're not going to go over each task in depth. We'll cover the browserify task and I'll paste in the rest, but we'll still briefly go over what each one does. To create a gulp task, you just type gulp.task. And this is a function that takes in a title, which in this case we'll call browserify. And it also takes in a callback function. Now to start things off, we need to grab the file that we need to send through browserify. We'll start by saying gulp.src. And within here, we need to get into our main.js file. So we'll say ./app/source/js/components/main.js. Now from here we can chain, so we can type .pipe. And within here, we're going to call the browserify plugin. And we're going to provide an option for transform, and we'll say reactify. So what pipe does is it takes the contents of this file and it throws it through browserify. Now that it's gone through browserify, we're going to pipe it one more time. And we're going to set it to a destination folder. So we'll type gulp.dest and we'll set the destination folder. So we want to say app/dist/js. Now let's just briefly go over the other tasks. This task is the open task. When we start up gulp, it'll launch a browser to this page so we don't have to open it. This is the local server with a live reload. We can set up the default port here as well. These tasks will call live reload whenever the HTML and JS files are changed. And this task will serve as the watcher. And whenever one of these file changes, we'll fire off its associated task. Our default gulp task will just browserify our code. If we type gulp serve, it'll browserify our code, set up the live server, launch it in a browser, and then watch for any changes. Now in the command line, let's type gulp serve. And this opens up our blank file. To check out the live reload, let's go and add something here. And by the time we've switched back to our app, it's already reloaded. Now that we have this build process set up, we'll define our component hierarchy and create a static version of our app in React. Hey everyone, in this lesson we're going to define our component hierarchy and create a static version of our project in React. The goal of this app is to display a feed of news items that can be voted on. We'll also provide the ability to create a new item in the feed. This is the static version in HTML. Before we write any React code, we need to take a look at our UI and see what components we can break down from it. The smallest component here is probably the news feed item. And this belongs inside of a feed list. Above this list, we have a form to submit new feed items. This should require a button that toggles whether the form should be shown. So let's mock this up in a comment. We know that the smallest item is the feed item, and the feed item is owned by the feed list. And we also have a way to create feed items with the feed form. And to show and toggle the feed form, we'll have this show add button. These components are all on the same level, so they don't have a top level component to hold the state. So in this case, where does the state get held? In these cases, we can create a top level component just to hold the state, and we'll call this component feed. This is the mock view of our React components. So from here, we can create all of our component files. And by looking at the structure, we'll know what we need to require for our dependencies. So inside of our components folder, let's start adding files. We'll add feed.js. We'll add show add button, as well as the feed form. We'll add the feed list, and then the individual feed item. And since we have this all set up as HTML, we can actually just return this from our render function. We'll have to change class to say class name, but this will render out a static version. Right here, I'm going to use a snippet to create a component, and we'll call this feed item. Now within our render function, let's copy our HTML, and that's this list item right here. We'll change all the instances to class name. Now that that's done, let's do the same for feed list. We'll use the snippet again, and we'll copy in this unordered list. And we know that this feed list will take in the feed item. And we'll want to render out multiple feed items. So we'll assume right now that we're getting them as props. And we'll just pass the title and description for now. And we'll add these inside our unordered list. Now let's add the HTML for our feed form. And next we'll grab the show add button. And lastly, we'll set all this up in our feed. We'll wrap everything in a div. And we'll start with our show hide button. We'll place that inside of a container. And below this, we'll do the feed form. And below that, we'll do the feed list. Now let's set some feed items to our initial state. We're just populating it right now with some dummy data. We'll pass our feed to the feed list. Now we'll set the rendering inside of main.js. To get our feed, we need to require it. And we know that's in ./components/feed. Now we'll go into our static HTML and we'll get rid of all this. The only thing that we'll leave is our Jumbotron, our mock structure, and this container node. And now let's reference our script file. And this is the distribution folder, js/main.js. If you were running gulp serve as this was running, it should have built out the distribution folder for you. But if you weren't, just run gulp serve now. When the page loads, we see that the show add button is not defined. So we'll click on that, and we can see that it's inside of our feed. And right here inside of our feed, all that we're requiring is React. So let's go and require our other components. We'll do our show add button, our feed form, and our feed list. With all of our dependencies required, let's check it out in the browser. In the browser, we have our stuff showing up, but there's a couple issues. Our container is kind of messed up here, and we're not displaying our props for our feed item. In our feed list, we can add another class to our class name, and we'll set this to container. Now in our feed item, rather than hard coding these names in, let's set the properties. And in our feed list, we'll have to make sure we're passing in vote count as well. Now back on our page, this looks just like our HTML static version, except in this case, it's all mocked up in React. In this lesson, we looked at our static HTML and we broke it down into a hierarchy of React components. From there, we were able to add them into separate files. We knew what the dependencies were because of the way we did our mock structure. Now that we have the static version, let's add the functionality to add a new story and change the votes. Hey everyone, in this lesson we're going to take the static version of our app and give it some life by adding some events. The first piece of functionality we'll focus on is creating a new feed item. This will have two effects on our state. We'll have to know how to toggle this form as open or closed, which will be a state property. We'll also have to be able to add this item to our state of feed items. By default, we want to hide this form. If this show form button is clicked, we'll toggle the CSS display property. We'll also change the button's text as well as CSS class. To set the default display to none, we need to give this an ID of feed form. There's a style we have written for this that'll set the display to none. Now let's set our callback function to toggle the display in our feed, and we can pass this down to the button. Inside of our state, we'll add our new property called form displayed, and by default, we'll set it to false. Now let's open up our button. Now we'll set up our callback and we'll call it onToggleForm. And inside of this button, we'll say onToggleForm, and we'll set it to this.onToggleForm. Now we'll open up our button. We can set an onClick handler now to this.props.onToggleForm. We now need to compute some values in the render method to display the text in the CSS class. We'll create variables for class string as well as our button text. Now we want to check to see if our form needs to be displayed. Back in our top level component, we want to pass this form displayed state property into this show add button. We'll set this show add button property to displayed, and we'll set this to the state property. Now inside our show add button, we can check to see if the prop displayed is true or false. Now if it's displayed, we want to set the class string to be a default class, and we'll set the button text to be cancel. To set these styles dynamically, we need to have our classes all in one string. If the form is not displayed, we'll set the class string to the success class. And we'll set the button text to create new item. Now within our button, we'll remove this hard-coded class name, and we'll set it to the class string. And we'll set the button text as well. Now let's set the callback back in our feed. We'll need to set state, and we'll set the form displayed to the opposite of the current display. So now when we click this button, we see cancel to create new item, but we're not showing up our feed. So let's go and add that into our feed form. In our feed form, we need to pass this property down. And in our render method, we'll decide whether the display will be block or none. Now we'll set our styles object, and we'll set that inside of our form. Now when we hit create new item, we can toggle our form. So let's wire up the ability to add a new item. Within this form, we want to handle when it's submitted, so we'll set onSubmit. And we'll call this.handleForm. And we'll set that up here. And we'll make sure to prevent default so the form doesn't post back. Now we need to add refs onto our text boxes. We'll call this one title, and this one short for description. We'll also give a ref to this form. In our handle form, we'll create a new item. We'll set its title, and now we'll also add the description, and we'll set a default vote count to 0. And when we submit, we'll want to grab the form from our refs, and we'll want to reset all our values. And at this point, if we had a callback on our property, we'd call it onNewItem. And from here, we just pass through our new item. So let's go back up to our feed and let's add this callback. And we'll pass this callback into our feed form. Inside of onNewItem, we can't just push onto the state array, so we'll need to create a new array and then set state from that. So inside of here, we'll call this .state.items, and we'll call concat. And that'll concatenate a new array, so we'll just pass this new item as an array. From here, we'll just set state, and we'll change the items to new items, and we'll make sure to set the form display to false. So now in our app, let's create a new item. We'll click add, and then down here we get our new item added. Just to recap, we created this new item from our refs, and then we called reset on the form, and we fired off this callback function. And this callback function was set up in our feed, and it creates a new array and adds that to our state. And this callback function is passed through to the feed form right here, and that's why we can call it within the feed form. Now that we can add new items, let's work on the voting. So how does voting mutate state? Well, every time we click a vote up or a vote down, we'll have to re-render. So in our top level component, let's create an onVote callback. And let's pass this onVote callback down through our feed list. And in our feed list, where we're creating our new feed items, let's pass that through here. And since we're calling this in the callback function, we'll have to make sure to bind this. So this context is the same as this context. Now in our feed item, we need to set up click handlers for voting up and voting down. So we'll just use onClick for both of these. And we'll have two functions, one for voting up, as well as one for voting down. And we can define these up here. And what we'll do here is we'll grab the count from the property, because we don't want to mutate our property directly. And then we'll create a new count, and that's just by adding 1 here. And we can do the same in our vote down by subtracting. And rather than calling the onVote callback inside of each of these methods, we can just create one vote method. And we can pass the new count into here. And now just to be sure of our type, let's parse an int. This way we know when we're adding, we're not going to be doing any string concatenation. Inside of this vote, we'll call the callback. And as the parameter, we're going to need to recreate the item. So we'll need the title, and we'll also need the description. And then we'll set the new vote count. So back in our feed, let's go and log this. So now we'll click up and we get a type error. So we'll click to see where it is, and it's where we're calling onVote. And this is telling us that onVote is undefined, so we're probably not setting it right. So let's go to our feed list. And in our feed list, we're calling this.onVote, where we want to call this.props.onVote. So we'll click up again, and now we can see that the vote count is 16 from 15. So now that we're getting the item back, we need to remove the old version from the array and then set the new item. To do that, we're going to need a key to uniquely identify each item. Up here, we're providing a key. So in our feed list, let's go and set a key. Keys will also allow React to avoid duplicates when rendering. In our feed item, we'll set the key to this list item. And now back in our feed, when we're creating a new item, we want to set the key. And we can do that by calling this.state.items.length. And this will just work for local data for now. Now when we vote up the item, we'll know which one it is through its key. So we want to get the index of this object. To make this a bit easier, we can use Lodash. We don't have Lodash installed, so we'll just go do that through the command line. We'll type npm install Lodash, and we'll save it to our dev dependencies. Now in our feed, we can require Lodash. And using Browserify, it's just as easy as that to add a new dependency. When we're voting, we want to make sure we're passing through our key as well. So to update the item with the new count, we have to do a couple of things. We need to find the item with the old value inside the state array. But since we don't want to mutate state directly, we'll create a unique copy of that array. We can do that through Lodash's unique function. Now our items array is just a copy of our state array. From here we want to find the index of the item with the old count. We can do that through Loadash's findIndex function. We'll search through our copy of the items. Inside of this callback function, we'll compare feedItems.key to item.key. Now we can find the old object by just passing through the index to the new array. So now we want to pull that item from the items array. And we'll use pull within Lodash. We'll pass through items, and we'll pull the old object from that array. And from here we can push the new item onto our items array. And now we'll call setState, and we'll update our items. So let's start to vote up, and we can see it works both ways. And now let's add a new item, and when we hit down, our negatives aren't in the red. So let's fix that real quick. To get the color to change for this, we need to change the class name of this badge. Inside of our render method, we'll set a check for that. Inside here, we'll do a ternary statement on the vote count. We'll check to see if the vote count is greater than or equal to 0. If it is, then we'll do badge success. If it's not, we'll say badge danger. And now inside this class name, we'll change that to use this positive negative class name. And now when we go into the negatives, it's red, but it's green when we go back into the positives. The last piece of functionality is to do the sorting when an item surpasses another in voting. And we'll do this when we implement the storing and syncing of our data in Firebase. We'll see how using Firebase and its real-time data model fits perfectly into React, and it'll actually reduce the amount of code we have to write. It may seem like this is a lot of code for adding a new vote, and this is because it doesn't fit well into React's data flow. So in the next lesson, we'll see how React fits well with real-time data. Hey everyone, in this lesson we're going to learn how we can use Firebase with React to easily make a real-time application. We touched on Firebase a bit earlier, but let's give a bit more of an overview. Firebase is a platform for building real-time applications. When you sign up for Firebase, you get a real-time database which is called a Firebase. Firebase is a NoSQL JSON data store, which can be accessed over a RESTful API. And this works well for AJAX requests, but Firebase has a vastly superior model than that. Using the Firebase.js library, we can set up listeners on our database. Whenever something updates in your Firebase, the data will be pushed down to all your clients in real time. What's important to understand here is that when we have data being pushed down to our React app, we can truly react to changes. To use Firebase, we need two things. We need an account, and we need the JavaScript client. I'd recommend creating an account rather than using the URL I'm doing for this example. The example I'm using is an unsecured demo Firebase that regularly gets erased by a backend process. You can go to firebase.com and create an account. To get the JS client, we can install it through npm and include it as a dependency in Browserify. In the terminal, we'll do an npm install of Firebase and we'll save it to our dev dependencies. Now in our feed component, we can require Firebase. To connect out to our Firebase, we need to create a reference. And to do the initial data loads, we need to use the component.didMount function. Right here, we can create a reference to our Firebase by saying var_ref equals new Firebase. And then within here is the URL out to your Firebase. For this one, I'm going to be using a demo Firebase, but I recommend using your own Firebase account. To sync data from Firebase, we need to set up a listener. To do that, we can use the on function. The first parameter the on function takes is the type of listener. In this case, we're going to use the value listener. The next parameter is the callback function that fires off when data is loaded. And this returns to us a snapshot. And a snapshot is more than just our data. A snapshot gives us helper methods that allow you to iterate through your data or to call a function to get the key name. In Firebase, our data comes back as an object. So we need to create this item array, loop through our object, and add each object to the array of items. One of the helper methods a snapshot gives you is snap.forEach. And each item it returns is a snapshot. So we can push onto the items array itemSnap.val, which will return the value of the snapshot. This just returns the value. We also want the key as well. So rather than just pushing the value, we'll create an item, we'll set it to its value, and then we'll set a key. And then on the snapshot, we can call a method called name, and this will return the key store from Firebase. Now we can push it onto the items array. Now that we have the items, we can call setState. We want to make sure that we're going to bind the context of this callback to our React component. And to make things more simple, let's pull it out of this component didMount function and put it into its own function called loadData. And inside our component didMount function, we'll call this .loadData. So to review this, we created a reference out to our Firebase using our URL. Then we set up a listener on our Firebase using the on function. And every time a value changes at this location of our Firebase, this callback function will fire off, which will set the state of our items. And currently this is pulling data from the root of our Firebase. We want to pull a location of a child node. By providing feed right there, we'll be able to create feed items at that URL, and then only pull those back, rather than pulling everything back from our Firebase. Now every time something in the feed node changes, we'll fire off this function, and we'll set state. And one of the awesome implications of this is that our data is being pushed down to us. We don't have to call back out to the server to see if anything's changed. And this fits really well into the flow of React. Every time something changes, we'll re-render. This also means that we don't have to call setState in any of our callbacks. All we have to do is update Firebase, which will trigger the callback inside of this loadData function, which we know will re-render our component. Down in our onNewItem callback, we just need to create a new item out to our Firebase. We'll create a reference. And to add data to this feed location, we want to append another child record to the feed. So a feed has multiple items. And to get a child with a unique key added to our feed, we can use the push method. So now we say ref.push new item. This will push data out to our Firebase, which will trigger out this loadData callback. And what you can notice from this is that we're just updating Firebase. We're not calling setState or creating a new array. All we have to do is update one data store, and we don't have to worry about how we change the local array of state. And since we're loading data in from Firebase, we can get rid of this local array, and we can set our default to an empty array. So now let's create a new item. And now we click add, it gets added to our page, and we can check out our Firebase to see that the item was stored. So now let's save the vote counts out to Firebase. And on vote, we had to find the old value to remove so we could add the new value. And we couldn't modify the state array, so we'd have to create a new array off of that. With Firebase, this is a lot easier. We'll create a reference again to the feed node. And to get the item, we can call .child, and we can say item.key. Since each item has a key, we can pull it back from the feed location. In this current example, this ID is what we created when we called push. And this is just auto-created by Firebase. When we call item.key, we're going to grab back this ID. And that's because right up here, where we're saying item.key equals itemSnap.name, we're setting it when we're loading. So to update data at that location, we can call ref.update. And then we can just pass through the item. So now back in our app, if we hit up, we see it marks out to 2. And then in our Firebase, we also see the 2 out here as well. So right here we have 2 tabs. And when I hit up on this tab, we can see the count is updating in real time. And this is just one of the benefits we get out of the box by working with Firebase. So now that we have the voting, we want to get the sorting of our stories down. Whenever one story takes over another story and votes, we want to see it resort. To add the sorting, we'll use a function in Lodash. Once we've looped through our snapshot and collected all of the data as an array, we'll call sort in Lodash. We'll create a variable for our sorted array, and right before we're calling setState, we'll set our sorted array to the result of this Lodash function. And this Lodash function is called sortBy. And we'll provide the array that we're sorting, which are the items. And in this callback function, we return the item, and then this is where we can do our comparison. In this case, we're going to return negative item.voteCount. And this will sort by descending order. In setState, rather than setting our state to items, we'll set them to sorted. You might find it a bit strange to do the sorting on the client. However, this isn't a problem in this case. Firebase is fast, Lodash is fast, our dataset is small, so it's not really a problem to sort on the client. So now let's create a new item here. and we click add, it gets added to both pages. So now let's vote up. And when we get to 6, we'll vote up one more to 7. And we can see that they swapped on both clients. In this lesson, we learned about Firebase. Firebase is a platform for building real-time apps. It gives us a database with a RESTful API. Anytime changes happen in our Firebase, our data will be sent down to all the connected clients in real time. And this is a perfect fit for React, since it wants to respond to updates. Using Firebase, we are able to cut down on our code because the Firebase listener will fire off a callback that allows us to re-render our app with our newest data. Really, all we had to do is create a listener, and then inside of the callback for this listener, we just had to create an array from our object, and then just set that sorted array to state. And to update any of these items, we didn't have to worry about where we call set state. We can push a new item when one is created, and then we can update one when we're doing the vote count. And this fires off everything inside of this callback function. Firebase is perfect for syncing our app's state in real time, and React is perfect for rendering that state.